Welcome to tutorial 15. This is our first lecture on functions, and we're going to cover domains, codomains, and images. As in tutorial today, you said that you may have heard the term domains and ranges, but the term range has been used for either codomain or image, and so to avoid confusion, I'm going to use these words instead. So a few words on set theory. A set is a collection of distinct elements e.g. 112 is equal to 12. A set may be finite, infinite, discrete, or continuous. And like in stats, let's just categorize it in this way. So if it's finite or infinite, and discrete or continuous. So finite sets are automatically discrete. So let me just give one example inside. So RBG, red, blue, green. So an infinite set that's discrete might be the natural numbers. Also, for instance, the all integers or even the rationals. And continuous, they can't be finite. But we could have something like R or C, or something a little bit more complicated like the half open, half closed interval. So here this includes 0, but this one does not, excludes 1. So what's a function? A function, often written f or some letter, consists of, well, it's 3 pieces of data: a domain, a codomain, and an assignment. So the domain is some set, usually say we call it X. A codomain is some set Y. And a map or an assignment which assigns each element of X to one and only one element of Y. For instance, pictorially, you might have, there's X, there's Y, and the assignment, let me use a different color, tells you where each element of X goes. It may go to the same element of Y, or a different one, but it may not hit every element of Y. But for those that are hit, that's the image. So the image is the set of points hit by F under the assignment. You can write this as the set Y in Y such that Y is equal to F of X for some X in X. So if we just look at this picture, here's some examples of functions. So from the natural numbers, that's all the positive integers, the natural numbers, and we square every positive integer. And the image is the set of square numbers. A function from the reals to the closed interval where and the image is everything. It's always a subset of the target. In this case, it's all of -1 to 1, because we know that sine takes values between -1 and 1, and it hits all those values. A more complicated one, so we take a complex number, and for z is equal to r comma theta p, this is any z in here. This is assigned to, we might also use this notation where it maps to the size of z. And in this case, the image is the non-negative reals. So it's those numbers from 0 up to infinity. Non-inclusive, because infinity is not an element of the real numbers. It's just the sizes of a complex number. Pictorially, if I give you a complex number, z, this complex number gets mapped to the size, which is that length. So those are some good examples of functions. So what are some bad examples? So here are some non-examples. So this looks very similar to before, but we've only defined this on the set of natural numbers contained inside of real numbers, so only on 1, 2, 3, and so on. So this is not fully defined. I should clarify, these are bad examples. Apologies that this should be A of n. Well, in this case, sine is defined on all values of the real numbers, but it lands outside of 0, 1. We saw earlier that in fact you do get negative numbers. So the image, which is the set of values actually taken, must lie inside of the codomain. This last one, this is just not well defined at all, because this is multi-valued. There's no unique square root when we take a complex number. Remember, in complex numbers, the whole point was that this is a collection of all the possible square roots, and there's 2 of them. So one thing that might be new is to consider maximal domains. That is, when we write something down like f of x is equal to root x minus 7, we forget to specify the domain and range. But it might be reasonable to consider f as mapping from some subset contained inside of the real numbers to R. And we want to find what's the biggest possible one. So we need to find the collection of bad points. where f is not defined. So my example here, so where is this bad? I need bad if x minus 7 is less than 0. I don't want to take a square root of a negative number if my image lies in the real numbers. So the maximum positive domain is what lies outside of this, and it's good. Let's do green for good. And so D is equal to the set 7 to infinity, which is the same thing as the set of elements x belonging to R, such that x is greater or equal to 7. Pictorially, you might see this as, you can draw this, and it makes sense to draw this provided, so here y is equal to f of x, provided that x is greater or equal to 7. So this is known as the graph of a function. So the graph of a function is the collection of points. It's a pairs